In this video, we're going to talk about errors, and we're going to talk about the types of errors that you might get, and we'll also talk about what precision and accuracy mean. In science, they're errors that creep into any experiment, okay, and that refers to the difference between the measured value and the true value. So you want to get the true value, the one it actually is, but your measured value is often very different, okay, and that's due to errors. So for example, you determine the boiling point of water to be 103, but the true value is 100. Okay, so you're 3 degrees out. So that's not an accurate measurement. Okay, so that's accuracy first of all. It has to be close to the true value. Now, why do these errors happen? They happen because of random errors. That means basically in the lab, the temperature may change in the lab from day to day. You may change the human being who's doing it, and their reactions are different. But basically, the really important thing for your exam and your tests are random errors can be minimized by taking multiple measurements and calculating an average. So just tell them, no, I'll get rid of this by doing more measurements and taking an average. Systematic errors. These are caused by faulty equipment that's not calibrated properly, and it'll give you incorrect readings. So the best way to do that is calibrate the equipment or use more accurate equipment with smaller graduations and smaller intervals, smaller divisions. Right. Okay, so let's look at accuracy and precision with our beautiful archery board here. And you can see we've got 4 arrows, and they're not grouped. And let's just say the true value is going to be the center right here. Now, if that's the case, they're not accurate. They're not accurate because they're not on the true value, which would be the center. Are they grouped together? No. So they're not precise. So if we're looking at precision, we're looking at values that are grouped together. So if I have a load of values that are very close to each other, they're precise, but they can still not be accurate, and we'll show you that in this. So here we go. This first one is not accurate and it's not precise. All right. Now, let's try another one after this and see if you can think about what you're going to see. Think about what you're going to see next. So accuracy and precision, this time we've got another set of arrows. Okay, well, they're grouped, right? Okay, so they're precise because they're grouped together. They're very close together, just like values. Numbers would be very close together. But are they in the true value in the center? No. So this is not accurate, okay, but it is precise. All right, let's go for the final one. So we have got these. They are grouped a tiny bit, but they're still a little bit, you know, can you see they're a little bit too far away? They're getting towards being accurate. So I'd say these are kind of accurate, but they're not precise because they're not grouped together. Let's try another one. And this is the one. So if you look here, you've got 4 arrows, all right in the center, okay, on the true value. So this is both accurate and precise. Okay, so imagine that in terms of numbers. Your numbers have to be close together and they have to be on the true value. And if that's the case, they're accurate and precise. Now, if that is the case, and you're doing this in the lab, you might find that one of your values is completely off in a different direction. That's called an anomaly. And you discard anomalies and don't use them in your final mean, your final average. Okay, so if we had 3 of these arrows in one place and then one was out here, we discard this arrow and say we're not going to use it. And we'll talk about that when we talk about graphs later on. As I hope that's been of use, okay, and like I said, as I say at the end all the time, please share, like, and subscribe like everyone does on YouTube, and enjoy.